All right, so we are going to be solving linear equations and inequalities. So something that we've done a lot of over the course of the algebra you've done. So reminder, an equation is a mathematical statement that two expressions are equivalent. If it asks for the solution set, that just means just tell us what the answer is. So find the solution. We're going to solve equations in one variable today. So we're going to be either solving for x or y or p or something like that. Okay. So we're going to be focusing on linear equations like 4x equals 8, 3x minus 2/3 x equals -9, and so on. All right, we're not going to use stuff that has square roots or variables in the denominator or exponents. Okay, so here's our first example. We're going to do an application problem. So we actually have to write the equation first of all. They're not going to give it to us. So here it says a local phone company charges $12.95 a month for the first 200 minutes of airtime, plus 7 cents for each additional minute. If Nina's bill for the month was $14.56, how many additional minutes did she use? So how do I go about solving this problem? Spencer?
Do 1456 minus 12.95, and then whatever that's up on divided by 0.07.
Okay. All right, that's exactly right. All right. Well, I want to see an equation, though. Can you give me an equation to solve it? David, can you?
No.
You agree with him? Okay. All right, that's exactly right. All right, that's what we're going to do to solve it. Carolyn?
$12.95 plus 7 cents equals $14.56.
Good. And then as Spencer said, we'll subtract 12.95 and divide by 0.07. Exactly. Okay, so 1456 minus 12.95 is $1.61, right? And then divide by 0.07. So what's $1.61 divided by 0.07? What is it? 23. So they talked for an additional 23 minutes. Okay. So with this problem, then you can write an equation to solve it if you can solve it without an equation because it doesn't say that you have to write one, then you can go ahead and do that. So solving equations with the distributive property. Here we have the equation 4 times the quantity m plus 12 equals -36. And so we're going to solve this two different ways. We're going to use method 1, where we're going to divide by 4 first, and then method 2, where we're going to distribute the 4 first. So you can do it either way, and we're going to look at it both ways and see that. So some of you will want to do it one way, others of you will want to do it the other way, and it will be basically up to you. So we write it down here, 4m plus 12 was -36. So the first method is to divide by 4. So since I have 4 times this whole quantity, I can get rid of that first of all. So I'm going to go ahead and do that. Divide both sides by 4 first. So then I'm just left with m plus 12 on the left side. And it actually, in this case, it's a little bit easier to do. Subtract 12, get m equals -21. And what's one thing we should always do when we are solving equations? Check your answer. So if it ever tells you that you need to check your answer, I expect that you will check your answer. Okay, so you need to show your work. All right, if we do the second method, distribute first, then we will get 4m plus 48 equals negative 36. So we multiplied everything by 4 to begin with. And then here's the problem that you've seen many times before. So we'll subtract 48 from both sides. Let's see, what is negative 36 minus 48? 84? Negative 84? Okay. All right. Negative 84. You guys agree with that? And divide by 4, and once again, we will get negative 21. So the method we use doesn't matter. It's like, how many of you would use the first method where you divide by 4 first? Okay, how many of you are more comfortable with the second method? Okay, so there, it's just a situation where pick the method you like and then go ahead and use that method. Okay. So I want you just to do B. Okay. Variables on both sides. So one thing we want to do, first of all, if we have variables on both sides, is look to see if anything needs to be simplified on one side or the other. Okay. So our first step is going to be to simplify each side. Then we're going to collect all variable terms on one side and all the constant terms on the other. And then isolate the variable we want to find. So on the left side, we can combine the 3k and then minus 14k. So that gives us a negative 11k plus 25. And on the other side, we can combine the, okay, 2 minus 12 is negative 10, so negative 10 minus 6k. Now, once I've simplified each side, and we want to get the variable terms on the same side, which one do I move? Okay, why do we want to move the smaller one? Not necessarily easier. Right, because, well, it's not necessarily a negative number, but by moving the smaller one, I'm always going to end up with a positive when I'm done. And some of the times when we're dividing and it's a negative, we forget the negative, or we divide incorrectly because of the negative, and this eliminates it. So we're looking at the two variable terms. We've got negative 11k and negative 6k. Which of those is smaller? Negative 11 or negative 6? Which is smaller? Negative 11 is smaller. So we're going to add 11k to both sides. All right, so we have 25 left on the left side. And then I'm going to change the order too. I'm going to make it negative 6 plus 11 is 5k minus 10. All right. Now, some of you may just prefer to work on the left-hand side. If you do, that's fine. Okay, it's totally up to you. But, a good habit is to work with it, move the smallest one so you're always working with a positive. So we add 10 to both sides. And divide by 5 so we get 7. And the advantage of this is by moving the smallest one, what we're dividing by is always a positive. Now we could have ended up with, if we would have added 6k to both sides first of all, we would have just ended up in that situation. We would have had negative 5k equals negative 35. Well, we still would have got 7. So it really wouldn't have mattered which way, but I prefer to work with a positive whenever I can. That way I don't forget the negative sign. Okay. All right. So let's do this, check it out. Okay, so we've solved equations that have a single solution. Some equations have an infinite number of solutions, and other ones have no solution at all. If we have an infinite number of solutions, it's called an identity, because that means that any number works. It's true for everything. And if there's no solution, then it's called a contradiction, right? Because it doesn't work at all. Right, so we're going to look at these two and figure out which one is an identity and which one's a contradiction. So as soon as both sides are completely equal to each other, you can say it's an identity. You don't have to take it down to the most basic thing, that if I have everything on the left side is equal to everything on the right side, then I'm done. I have an infinite number of solutions. It's an identity. All right, so let's look at A. So we have 3v minus 4v is negative v minus 9 equals negative 5 minus v. And I'm going to tell you, after we finish this, I'm going to tell you how you can recognize a contradiction right away also. Okay? So now if we want to get the v's on the same side, right? So if I add v to both sides, because that's the smallest v I have, we get negative 9 equals negative 5. Is negative 9 ever equal to negative 5? No. So this is a contradiction. Right? And there's no solution. All right, and the key to finding that is as soon as you see the same variable term, once you've simplified it, if you have the same variable term on each side, well, when I either add or subtract that variable, it's going to cancel them out. Okay? So as soon as I see the same variable on both sides, like we do here with the negative v, I know immediately then it's going to be a contradiction, no solution. Okay? For it to be an identity, we're just looking to see when are both sides equal to each other. So here we've got 2x minus 12 equals negative 5x plus 7x is 2x and minus 12. So now I'm done. Once I see that both sides are exactly the same, if I kept going, I would get 0 equals 0, okay? Which is always true. So then this is an identity. And there's an infinite number of solutions. Right? So those are the answers we expect to see. You know, tell me it's a contradiction, so there's no solution, or tell me it's an identity and there's an infinite number of solutions. And so we're looking for contradiction as soon as the variables on both sides are the same. For an identity, it's the whole side is exactly the same as the other side. All right, we also have inequalities. So when we do inequalities, we're probably going to, or I should say we are going to graph our answer on a number line also. So what's the one thing I have to be careful of when I'm solving inequalities? There's one very important thing. Everything else is the same as when I'm solving equations except for what? Gibson?
When you divide from one side to the other, you have to switch around the greater than or less than sign.
Every time I divide?
Or you divide negative.
Divide by a negative. Okay, good. All right. So if we divide by a negative, we have to switch the direction of an inequality sign. So that's, other than that, it's exactly the same as the other ones. And this is where it's really important that when I move a variable from one side to the other, I'm always moving the smallest one. That way I always end up with a positive, and I don't have to worry about dividing by a negative. Okay. So we're going to solve and graph 8a minus 2 is greater than or equal to 13a plus 8. So we always move the smallest variable term first. Is that 8a or 13a? 8a. Okay, so we'll subtract 8a from both sides. So we get negative 2 is greater than or equal to 5a plus 8. And the advantage here is that the 5a is positive. If we would have subtracted 13a, we would end up with negative 5a on the other side, and would have to make sure we switch the inequality. So we subtract 8 from both sides. We get negative 10 is greater than or equal to 5a. Divide by 5. And a is less than or equal to negative 2. So if I make my number line then, like I said, all you need is 3 numbers, okay, in this situation. All I need is the number I'm working with, one below it, and one above it. Okay. So this says a is less than or equal to negative 2. Open or close dot? Close dot. All right, so we're going to put a close dot here. There's our close dot. And which direction are we going? Left or right? Left. Left. Okay, so a is less than or equal to negative 2. Make sure you bold it in. Make sure you put an arrow there. Now you could always check a number to see if it's right, because I could check 0, right? That's my favorite number. Okay, so if I put 0 in here, is negative 2 greater than or equal to 0? No, it's not. Okay, so then 0 would be false, so it definitely goes the other direction.